Okay, so we just talk about the variation of parameters. So last time, so that's another method to find a particular solution for the non-homogeneous differential equation. The other method is the undetermined coefficients. We have two different approaches with undetermined coefficients. You can do it either by superposition approach or annihilation approach by using the operators. Okay. But the problem is the undetermined coefficients method does not solve all the problems. It only works when the right-hand side of the equation, fx, the differential equation, when the fx on the right side is either a polynomial or a exponential function or sine or cosine function, or combination of them with multiplication. But for other functions, f on the right side of the differential equation, the undetermined coefficients method does not work. So for example, if you have a secant x or cosecant x, or even tangent x, cotangent x, and also some other rational functions, for example, logarithm, the method doesn't work. So in order to solve this problem, then we just introduce the variation parameters method that works for all the functions, at least in principle. So the variational parameters is a different approach. All right, it just assumes the particular solution or it derives the particular solution as some function u1 times y1 plus some other function u2 times y2, where y1 y2 are the two linearly independent solutions for the associated homogeneous differential equation. And we're talking about how the linear differential equation. Specifically here, we're talking about second order differential equation. Okay, so we just write the particular solution we want to find in this form, and then using the condition that y1 and y2 are both solutions to the associated homogeneous differential equation, and then we got the equation to solve, with two functions, u1, u2, to determine, but we only have one equation for them. So that gives us a lot of freedom to choose what u1, u2 can be. And we just choose the easiest way to do it. We just have some gauge or whatever condition, and then that will put another equation to u1, u2, or u1 prime, u2 prime, and then we just solve for u1 prime, u2 prime easily from this system of equations, and then you just integrate u1 prime, u2 prime to get u1, u2 after this process, and then then we get the particular solution of the non-homogeneous differential equation for a particular solution. So we just choose because some form of u1, u2. So that's the basic idea of variation of parameters. So we just use this formula when we actually do the problems. We don't have to go through all the steps again. Just plug in those functions into the formula and they get u1, u2, or u1 prime, u2 prime. We did one example last time Let's just do another example. So this time we need to solve the differential equation for y dou prime plus 36y equal to cosecant 3x. So again, the right hand side of the equation is a trig function other than sine or cosine. So you cannot use the method of undetermined coefficients, at least directly. So why don't we just try, regression parameters? So we're going to rewrite the equation first a little bit to make the coefficient of y dou prime to be 1. So the original equation was 4y dou prime plus 36y equal to cosecant 3x. So we're going to divide by 4 on both sides. And to get y dou prime plus 9y plus equals 1/4 cosecant 3x. Okay. And that's required, See, we started from this equation when we derived the formula. So if the coefficient of y dou prime is not 1, then you have to make it 1. Okay, then you can use the formula. So that's the very step. If you don't miss that. So we got a new equation here that tells us f is 1/4 times cosecant 3x. Now we can just plug in the formula using those functions. But first we need to find the two linear independent solutions for the associated homogeneous equation. So just drop this 1/4 cosecant 3x and put a 0. We got y dou prime plus 9y equal to 0, and we can easily solve it by plug in y equal to e to the mx. And after some simplification, you end up with the auxiliary equation m squared plus 9 equals 0. Okay, that's always the case. You always get these kind of things. And you can easily solve this equation by moving 9 to the right. So we got m squared equal to -9, and just take the root. So you got 2 roots plus or minus 3i. Okay, so they're pure imaginary. So that also means, if you remember, that also gives us the 2 linearly independent solutions for the associated homogeneous equation, which are cosine 3x and sine 3x. Okay, so we don't have any exponential part for this y1 or 2 because the solution for this quadratic equation are pure imaginary, and because there is 3 in here, 3 times so that's why we got 3x, cosine 3x, sine 3x. Okay, so if there's no real part for m, then you don't have any exponential part. You only have sine or cosine functions. All right. So then the next step is to write yp as u1 times y1 plus u2 times y2. Okay, this for the standard procedure we did. And the formulas we obtained before, just rewriting here. So this u1 prime is negative y2f over y1 y2 prime minus y1 prime y2, and the u2 prime is just y1f over y1 y2 prime minus y1 prime y2. Okay, so we need to plug in all these functions, y1 y2 and also f, into this 2 equations to figure out u1 prime and u2 prime. So y2 is just sine 3x, and f is 1/4 cosecant 3x, and y1 is cosine 3x. So just plug in everything here. Now you just take the derivative from sine 3x and the cosine 3x. Okay, so we got the cosine 3x times derivative of 3x, which is 3. Similarly, the derivative of cosine 3x is just negative 3 sine 3x times the derivative of 3x, which is also 3. So we got in here. Then the denominator will be becoming 3 times cosine 3x squared plus 3 times sine 3x squared. Remember, 2 minus in here. That'll be plus. So then, because cosine 3x squared plus sine 3x squared is just 1, so we just got 3 in the denominator. And negative 1/4 over 3 is negative 1/12. So you should know how to divide fractions. So that's U1 prime. Very simple. We can do a similar thing to U2 prime. Just plug in those functions in here. I'm not going to repeat. And take the derivative of sine 3x and cosine 3x also. The denominator is actually the same, okay? Because in the formulas, they have the same denominator, but the numerator is a little different. This time, we got cosine 3x. So again, the denominator is just 3, and you get a 1/4 on the top. So that becomes 1/12. So that's why you could trim in the denominator. And then we get cosine 3x times cosecant 3x. That's the whole thing. But the cosecant 3x, if you remember, they reciprocal property for trig functions, that's just 1/sine 3x. So you put sine 3x in at the bottom. So the whole thing is just cosine 3x over 12 sine 3x. So that's U2 prime. So then you just integrate U1 prime, U2 prime. So U1 prime is just very simple. Integrate negative 1 over 12, because negative 1 over 12x. Again, we don't worry about the arbitrary constant because we have the freedom to choose it. We just need to find one particular solution of the differential equation. And you can actually integrate U2 prime to get U2 easily. If you use the substitution, U equals sine 3x. Okay. If you do that, remember. So if you do that, you're gonna get the du over 3 times divided by 12u. Okay, and then you just actually negative. I'm sorry here. Oh no, it's no negative. And then you just integrate 1/u, but you get 1/3 on the top and 12 at the bottom, so that makes 1/36. And when you integrate u over du, you get a natural log of absolute u, which is 3 sine 3x. So again, we don't have to worry about the arbitrary constant. So these are U1 and U2. So plug in these two functions into YP. So we got YP equals U1 Y1 plus U2 Y2. So that's negative 12, 1/12x times cosine 3x plus 1/36 sine 3x and natural log absolute sine 3x. Okay. So then now we can write down the solution of the original nonlinear differential equation. Remember, it includes two parts. The part from the associated homogeneous equation, which is C1 Y1 plus C2 Y2, as we already found, and plus the particular solution we got. So that's just C1 cosine 3x plus C2 sine 3x plus negative 1/12x cosine 3x, or just the minus 1/12x cosine 3x plus 1/36 sine 3x times natural log of absolute sine 3x. So that's the final answer for this problem. So we can, solve this nonlinear differential equation by the method of variation of parameters. where the undetermined coefficients method fails. So that's the end of this section. Any questions about this example?